Okay, again, this definition is really key, so please don't just do square roots by autopilot. Take your square root problem. If you are given second root of some number like 81, I mean, you may know that it's 9, but think about it in this fashion. Think about how you would be given if you're asked the second root of 81, that you'd have the yellow and the blue information. You should stick those in the appropriate places in the other equation to figure out what would be the missing base and then answer that, right? So 9 is the missing number raised to the second equals 81. Again, you might be super comfortable with this for square roots, but if you don't think about it this way, you'll get stuck when thinking about third roots and fourth roots. And the point is, no matter what little number appears just outside the radical symbol, this approach is going to work each time. Now, to move on to the next thing, based on this definition, seeing that if you take a and then you nth root, you get y, versus if you start with y and you take to the nth power, you get a, you'll see this kind of informally that the nth root is actually undoing the nth power. Now, because the nth root and the nth power undo each other, there are these two new formulas. That is, if you start with a number a and you take the nth root and you take the result and you raise to the nth power, you get back a. Versus a slightly different version, if you just do the two operations in a different order. Start with a again, raise a to the nth power, and then you have a to the nth. Take that new number and do the nth root, then you get back a. So this is how the nth power and the nth root undo each other. So you start with a, you do two processes, and you get back a. The two processes are either to raise to the nth power first, and or take an nth root first, and then do the other thing second, right? So whether you start with a and do nth root then nth power, or start with a and do nth power first then nth root second, you get back a. Okay, so again, if this first formula here is saying if you start with a number, let's call it a, then take the nth root, then take the result, raise to the nth power, you get back a. Okay, so let's take a look at, I mean, these two formulas, don't overthink using these. Look at seventh root of 31, quantity raised to the seventh power. That fits the format of the first formula, and that's just going to give you back a 31. For an example of the second formula, the ninth root of, and then inside the radical is 5 to the ninth power. Notice this 9 is inside the radical. You be sure on your own page to draw it carefully. That's going to simplify to just a 5. So these two formulas here, when they apply, there's not a lot of work to do. It just takes this wacky situation of having both an nth power and an nth root and makes it really nice because there's just an a here, right? So that's why this side is just a 5. Notice one thing we did was we didn't bother doing 5 to the ninth power, whether in a calculator or by hand or anything like that. We just looked at how it fits the format of the formula and said, look at how nice it simplifies on the other side. The formula is just going to tell us we just get a 5. Okay, so we have these two formulas on the previous slide, and now I'd like to argue why the nth root of a is equal to a to the power 1 over n. So now, sorry for how this is written, but this exponent is the fraction 1 over n. I tried to write it using a standard horizontal fraction bar, but that everything looked a little too small. So sorry for the slash-like notation here. How are we going to argue why this new formula is true? I'd like us to, just for a moment, it seems bizarre, but look at the expression a to the 1 over nth power in parentheses raised to the nth power. Where did I get this? I just happened to look at the right side and I just put it in parentheses raised to the nth. I just want to look at this on its own off to the side for a second. So let's look at that, right? I just copy pasted. And now look, we've got base raised to an exponent. The exponent is a fraction. And then in parentheses raised to another exponent. There's a formula that applies there. I'd like to recall that that formula is when you have base raised to an exponent and then in parentheses and then raised to an exponent, you have to multiply the exponents. Now take a look. In the exponent area, you have 1 over n times n. It's a little awkward to multiply a non-fraction and a fraction, so let's turn that n into a fraction. And then remember to multiply fractions, you multiply straight across. Sorry, I wish this font were just a little smaller, but this is a raised to the power n over n. And n over n simplifies to 1 because, well, that's the cats in boxes interpretation of fractions, right? N cats, n boxes, 1 cat per box. And then a to the first, well, we don't have to write that first power. So we're now using an exponent rule to get a. Cool. So there's all this work that we showed along the way. fraction rules and exponent rules and more exponent rules. But in summary, now skipping the work in between, if you take a to the 1 over nth power, quantity raised to the nth, that's going to equal, and I just copy the right side, that'll just give you a. Now here's the funny thing. Also, just up here, the formula from the previous slide, the nth root of a, quantity raised to the nth power, is also equal to a. Now, take a look at this. Look at both of these. In both of these, you have something in parentheses. In both cases, something's in parentheses. And then that thing is raised to the nth power in both cases. And on the other side, you've got equals and a. So if this thingy in parentheses, which I've highlighted in yellow, raised to the nth equals a, and this other thingy that's in parentheses, I've also highlighted it in yellow, raised to the nth power equals a, then it must mean that the two things in the yellow boxes, while they look different, they must be equal. So the nth root of a, that's one of the yellow boxes, is equal to a to the 1 over n power. That's the other yellow box. It's a long-winded argument, but that is an argument for why this formula at the top where the question is true. So nth root of a is equal to a to the 1 over nth power.